Hi, I'm Sebastián Montaone, and in this video you will be learning how to access raw data from the Intel RealSense 3D camera, model F200. In this lesson you will understand what the camera streams are. You will also learn how to access them in different ways. This is very important because this is the first step to actually create any type of interactive application or games in 3D using this camera. The only requirement to follow this class is to know how to program in C++. You don't need any prior image processing experience. The F200 camera provides three different streams: color, infrared, and depth. The color stream is just a normal camera. The infrared stream is basically a camera that is more sensitive to infrared light. Finally, the more important one, the depth stream, is basically information about the distance of each object. As you can see here in this example, objects that are closer to the camera appear darker compared to objects that are farther away. You can also notice that there's a pink color in this image. That color represents a special value, and that means that for those pixels we don't have a specific distance for those objects. That could be explained for different reasons, but for this video you can just ignore those values. This is a diagram of the 3D camera. It has three components: an infrared camera, a color camera, and an infrared projector. As I said before, the color stream is just a color camera, and the infrared stream is just the infrared camera. But the depth stream is a little bit more complex than that. It combines the information of the infrared projector and the infrared camera. I won't go into details about how it actually gets created, but I wanted to show you this so that you know that these three streams are independent. Different streams will create images at slightly different times. That's why the camera provides two ways of accessing the images. In the align or synchronize method, a new frame will only be available once all the streams contains at least one frame available. In the unaligned method, the camera actually will send a new frame anytime any of the streams contain a new image. Which one is better will depend on your application. If you want to combine the information from two or more streams, then you should use the align method. If you just want to get independent information from the streams as fast as possible, then you can use the unaligned method. Now I'm going to show you the code in 4 examples. The first two are going to be a single-threaded application that shows how to get access to the images using the aligned and the unaligned methods. In the next two examples, the number 3 and number 4, we're going to be using the same techniques but in a multi-threaded application. Let's see some code. The first thing that you need to do is to include a RealSense Manager header file. We're also going to use OpenCV to make the code easier, but you don't really need to use OpenCV to work with RealSense. This method here allows us to change a RealSense image into an OpenCV image. I won't go into details right now. Let's go to the main definition first. The first thing to do here is to define some parameters for the image. In this case, I'm setting the resolution of the image of 640 and 480 and a frame rate of 60. Then what I'm doing here is basically just creating 3 windows and 3 images. This is just for displaying the images on the screen. This is the first line that actually uses RealSense. The first thing to do here is to create an instance of the manager. Then you need to enable all the streams that you want to use, specifying the type of the stream and also the resolution and the frame rate. Once you do that, then you can start the pipeline by just calling init. Now we're ready to go to the main loop of the application. The first thing to do here is to acquire frame. This line actually will block the execution of code until all the frames are available on all the streams. Once we have the images ready, we can access them through an object called sample. You can get the sample object by just calling this method, query sample. In this point, you can actually access the raw data of the RealSense image and do whatever you want with them. In this case, I'm going to convert them into OpenCV and display them into the screen. That's what actually I'm doing here. I'm converting them into OpenCV here, and then I'm displaying them here. Then I'm checking for user input here, and if the user presses the escape key, which has an ASCII value of 27, the execution will stop. At the end of the frame, you need to call this method, which actually releases the memory used by the frame. Remember, anytime that you call acquire frame, you need to call release frame. Otherwise, you'll start using more and more memory and you'll have problem in your applications. Once the application is finished, the next thing to do is actually release the memory used by the RealSense manager. Anytime that you use this method here, create instance, you need to release that memory using release. So that's a general introduction of how you actually can get images from the camera. Let's see in detail how we convert a RealSense image into an OpenCV image. You can see here that we're calling that method with two arguments, the RealSense image and the format that we want. Let's go in and see the code for this. The first thing to do is actually acquire access to that image. You have to specify the type of access that you want. In this case, we just need access to read the image. And also you need to specify the format and where you want this data to be stored. After you do that, then you can actually have access to information of the image, like width and height, and also the format if it wasn't specified. Then what we do here is basically changing the format from RealSense to a format that OpenCV understands. After that, we just call this method, which creates an image in OpenCV with the specific resolution of the RealSense image, the type that we just specified, and here is where the actual image memory is stored inside the planes variable of data. After we do that, we can just release access of the data and we can just return the OpenCV image. So now you know how to actually get information from the camera. Let's see how it looks if we execute this. As you can see, we have the color image here in one window, another window with the infrared camera, and another one with the depth information. Anytime that you press escape key, the program will stop. So if I press escape, the program stops. So let's go and see the second example, which will cover how to read images using the unaligned method. So the program in general is basically the same. The main difference is here in the acquire frame call. Here you need to call it with a false argument. This means that the code execution will stop and will only continue when any of the samples actually contains a frame. That means that in here, some of these images are not going to be an actual image. So in order to check for that, you have to add an extra line here to check if there's actually an image there first. If there's an image, then you can continue and convert that into an OpenCV and display them, or do any type of processing that you want. So let's see how it looks. We select that here and we call it. And it should be pretty much the same. So as we can see here, we're calling this as fast as possible, and we're actually updating the frames as they come in. So we're not waiting for all the other frames from the other streams, we're just updating them as they come. If we press escape, it closes. And yeah, so for some other applications where you need to have some more processing, you usually need to have this in another thread. So let's do exactly that and process this in another thread. Let's go to example 3. So in example 3, we first have to define the images here as global variables, just to make this simple. And we also need to define mutex. Basically, this allows to have a mutual exclusive access to the frames, because you don't want to have two threads accessing the same memory. Of course, you can do this in many different ways, and I'm just using OpenCV to make this thing simple, but you can use any other approach that you prefer. So in here we have the same method that we had before, the same thing. This is a new thing. We have a frames handler, which is a custom name. You can change this to anything that you want. Basically, it's as a class derived from the RealSense Manager handler class, and basically this is the method that gets called whenever a new sample is ready. So you need to specify what you want to do on every new sample, and we're basically doing the same thing that we did in the main loop, but this is in a new thread. So we're just checking if there's an image here in infrared, color, or depth, and we're just converting them into OpenCV. So basically it's the same execution of code, but it's done in a new thread, right? So let's go and see the main code for this. It's everything is the same. We enable the streams in the same way. We create a handler. We create an object of this class that we just defined here, and then we initialize the pipeline using this as an argument. This is the main difference from the previous example. Then we call this method, which basically creates the new thread and starts doing the acquire frame and release frame for us in a new thread. And this argument here basically tells us if you want this method to be a blocking method or a non-blocking method. It depends on your application. In this case, I'm using false because I don't want this method to be a blocking method for this particular application. If you want the application to be blocked, you can call this with a true argument here. Then what I'm doing here is just basically having a local copy of the images for display, and in the main loop here, instead of acquiring and releasing the frames, the only thing that I'm doing here is basically copying the images from one thread to the other. So we acquire the lock here of the frames, and then we unlock it here. We copy the images, and then we display them. So this is the main thread. Notice that we're not actually acquiring and releasing the images here. We're just copying the images from the main thread, which is actually being executed here. And after we're done with this, the next step is to actually call the close method. This close method stops the extra thread from running. So remember, anytime that you call stream frames, you need to call this method here to stop the execution of that thread. And the same as before, we just call release to release the memory used by the RealSense Manager here. And we can check this. We go to example 3, we execute it, and we should see something similar. So as you see here, we see something very similar. The only thing is that now we're using two threads. The main thread is just displaying the information, and the new thread is actually acquiring the images. So in any example or any application that needs to be processing this in a more complex way, this is the way of doing it, doing this in a new thread. Okay, so what happens if you actually want to do this, but instead of doing this with the unaligned way, you want to use this with the aligned way? That's exactly what we're going to do in the next example. So on example 4, we have a very similar structure compared to example 3. We have also the frames handler, and it's basically the same thing. The main difference is that now we need to call, instead of calling 3 independent enable stream calls, we need to call a single one with a slightly more advanced description of the streams. We need to create a data descriptor from the video module of RealSense, and then we need to specify all the streams that we want using this call here. If we do that, then we can just call enable streams, and that means that we want to have all of them aligned in time or synchronized. The rest is just the same as the previous example. We create an object of the handler and then initialize the pipeline with that, and then we stream frames. So the rest of the program is exactly the same as the previous one. And remember, anytime that you call stream frames, you need to call this method here to close the execution of that thread. And again, you need to release the RealSense Manager memory anytime that you create an instance of that. And the rest is just the same. So, for example, here in the main loop, or here, you can actually see that I don't really need to check if the images are there, because in this case we're using the synchronized method. So that means that anytime that we're here, all these three images, sample infrared, sample color, and sample depth, they're all there. There's never going to be a case, unless there's an error in the image, that we actually have one image and not the other, for example. So let's see how it looks when we run it. And we can see that it's there, similar to the other ones. And that's it. Now you have a more understanding of how you actually can get access to the images from the camera. You know how to access them in two different ways, and also using single or multi-threaded applications.